Welcome back to another exam walkthrough series. We're going to be going through questions on circular motion. So this is the first question that we're going to be going through. 2022 June, Unit 4, question 17. Just go through this question and then I'll solve it. Hammer throwing is an Olympic sport. A hammer is a metal sphere attached to a chain. An athlete holds the chain and spins around so that the sphere moves in a circle. The chain is inclined at 40 degrees to the horizontal as shown. So here I have a man and he's doing the same thing. He's going to be spinning the chain around and moving the metal ball and then launching it. And I will show you a video, so this clip will cut and it will show you a video. So I hope you have watched that video. In that you could see the man, he is moving the chain and he's moving it and then he throws it. And it isn't a perfectly horizontal or vertical circle. He's moving it at different angles and he launches it. So that's something that I want to highlight, which I'll speak about later on. And in part A, they're going to tell me that the tension in the chain acting on the sphere is T, and we have to draw the free body diagram. So first you want to draw the tension on the metal sphere because of the chain. And you want to make sure when you draw it on the free body diagram that when we look at the tension force with the eye, the angle is going to be 40 degrees. You can do it with the protractor as well, or just make a rough approximation. The second force is going to be the weight of the metal chain. I think that's quite obvious. So you want to approximate angle of 40. So it's going to be 40, and then you want to label it tension T. And then you want to erase this because we don't want to include this on the free body diagram. So that's your tension, and then you want to draw your weight force. So that will be your weight force. So I've pulled the tension back. I basically moved it like this so that we have the tip to toe rule or head to tail, and we can then draw the resultant force. This is something we have studied in Unit 1. And this is going to be the direction of the resultant force. And this resultant force is actually equals to the centripetal force. The reason I had shown you this man moving around the chain, so you could understand that the centripetal force here is going to be in the direction of the resultant force. Many students, they get confused because they assume the metal sphere is going to be moving like this, or it's going to be moving like this. But instead, it's kind of moving in a way that looks like this. Something like this, something like this. Not exactly vertical or horizontal like you would expect. And that's why we can say that the resultant force is equal to the centripetal force. And that is a good segue into the next part of the question, which says explain why the sphere moves with circular motion. So here's going to be your answer. The T, the tension and the weight exert a resultant force on the metal sphere. That's going to give you 1 mark. And the direction of the resultant force is towards the center of the circular motion. That's going to give you your 2nd mark. So basically your resultant force is your centripetal force. So I hope this question is clear till here. Let's move on to the 3rd part. So this one is a bit easier. So they have given us the circle completes 2.8 revolutions per second. And they want us to find the acceleration of the sphere. So we have these 2 formulas for centripetal acceleration. I'm going to pick this one. Okay. And then they've given us the distance from the center of the circle and the sphere, the distance between that. So they've given us this distance right over here. And this is basically the radius. So 1.5 meters is the radius. Now what I want to do is I want to find omega. I want to find the angular velocity. And I can find the angular velocity by doing 2.8 revolutions times 2 pi radian divided by 1 second times 1 revolution. the revolution cancels out, and you're going to get 2.8 times 2 pi radian divided by 1 second. And we're going to get 17.59 rad per second. And now what we're going to do is we're going to take this, square it times 1.5. Remember, I'm just applying that formula. And then I'm going to get the answer as 480 meter per second square. So that's going to be my answer. Okay, now similar to how I had shown you the video, the athlete here will release the sphere, and the sphere will have the velocity of 28 meters per second at an angle of 40 degrees to the horizontal. She releases the sphere at a height of 1.5 meters above the ground. The women's Olympic record distance for the hammer throw is 83 meters, and we have to tell if the athlete will break the record. So this is a projectile motion question, and you might be surprised to see this in Unit 4. Well, it is there, and it is a 5 marker right over here, and it is kind of similar to Unit 1 question. So if you are strong on Unit 1, this should be easy. I've drawn a diagram here to help understand what's going on. So we're going to have the sphere. It's going to be launched with a velocity of 28 meters per second at an angle of 40 degrees to the horizontal, and it's launched at a height of 1.5 meters. So we have to calculate the horizontal distance. So horizontal distance after the ball goes up, comes back down. So this is the horizontal distance that we have to calculate. So the first thing I want to do is I want to split my velocity into two components. This is going to be 28 cos 40, and this is going to be 28 sine 40. So I'm going to write that down. So this is going to get me 1 mark right over here. Now, what we want to do next is we want to see what we can do with the vertical motion. Now, what I really need here is we really know that horizontal motion has only one equation. Sx is equals to ux t. We already know the value of the initial velocity. All we need to do is find the value of time taken to go from here to here. That's all we need, the time taken. And once we find the value of time, we multiply the value of time with the initial horizontal velocity, and bam, we get the horizontal distance. So the easiest and quickest way to do this is applying S is equals to ut plus half at squared, the quickest way. And then the displacement that you're going to get, so I'm going to pick this point here as my 0, and my displacement when I go below and reach here will be minus 1.5 meters. So I'm displacing from 0 and I'm going down minus 1.5, given that my down is negative and up is positive. So we're going from 0 to minus 1.5. So my displacement is minus 1.5 is equals to u, which is going to be 28 sine 40 t plus half minus 9.81, because gravity acts down, negative t squared. Okay. And then this gives us a quadratic equation. We just rearrange and solve. So I've rearranged, now I'll solve. So you can just click your calculator, go on the mode setup button, click on it, and then go click 5, and then click 3. So you're going to go to the equation section and then click the quadratic equation and then plug in the values. Okay, so if you don't take math, that's the information for you. And now we're just going to solve it and get the two values of t. So we get two values of t. One is negative. We don't want that. We want the positive value because time cannot be negative. And then all we do is we do Sx is equals to 28 cos 40 times 3.75. This is going to give us the horizontal distance. And that's going to be 80.4 meters, which is obviously less than 83 meters. So the athlete did not break the record.